Hi, I'm Jasmine Lai, and today I will be speaking on behalf of our team on the topic Building a Custom Ontology for the MOSAiC Expedition Datasets. The MOSAiC expedition took place over a year, starting in September 2019, involving multidisciplinary research conducted on board the Polar Stern icebreaker and associated vessels. The Arctic Data Center is the primary data and software repository for the Arctic section of the National Science Foundation's Office of Polar Programs. And over the next year, we will coordinate with the NSF-funded researchers to have their legacy documented. The Arctic Data Center uses the metadata language EML to describe their data sets. However, the MOSAiC expedition has its own specific terminology, but doesn't align with the metadata fields currently in EML. These terms may be clear to MOSAiC researchers, but not for others searching for these data sets. Our solution was to build an ontology to help others trying to find and reuse MOSAiC datasets, as well as better understand the underlying connections among terms. The ontology organizes terms according to their types and provides descriptions and other metadata about them. Here we have classified items from the preceding slide by type. The ontology is also aligned with the vocabulary around event IDs at the PANGAEA data repository. The MOSAiC ontology is built according to W3C recommendations for the semantic web, using RDF and OWL to facilitate interoperability. By creating the ontology using W3C recommended languages and frameworks, the ontology is not only machine actionable, but also readily shared, revised, and extended. In addition, the ontology can capture relationships among types. For example, the ontology can describe what was the basis for a campaign and what was the research location for that campaign. Relationships among types are also defined in the ontology. For example, campaign PS122/5 has a basis Polar Stern, a chief scientist Rex Marcus, and a research location of North Greenland Sea. All the terms in the ontology has unique HTTP URIs and can include descriptions, relationships, and instances of the class. Using HTTP URIs, we can semantically annotate EML metadata. For MOSAiC datasets, we have added dataset and attribute level annotations, revealing connections that weren't explicit before. We can search for more data sets using these annotations. And for example, here we can browse for different temperature measurement types and keep expanding the tree for further options. If we find an interesting term, we can search for all the data sets annotated with it. Then at a particular data set, we can explore these semantic connections further. One can click into a term such as PS122/2 to get more information in a popover. This is not only valuable for users exploring the definition, but also for increasing the precision of data searches. Farther down, we can search for other data sets by clicking on the More Datasets link. Note, as of today, we have not exposed all of the features of the ontology through our website's user interface, but these are possibilities for future development. There's also a customized data portal for all of the MOSAiC data. In the portal, you'll find multiple markdown pages with details on the research expedition. And over on the data page, it shows all the data sets from this expedition. There are also custom data filters that highlight all the search options. And with the annotations, we can ensure that these filters are accurate and precise. The MOSAiC expedition is an excellent use case for this functionality, and we hope to use custom vocabularies more in data portals in the future. And with that, thank you all for listening. I would also like to take this time to acknowledge everyone who helped work on this project, in particular, Dana Ransby and Matt Jones, for answering all of our questions.